Okay, this lesson we're going to cover powers and exponents. Powers and exponents are essentially the same words and the same meaning, and let me show you what I mean. Let's say, for example, you've got the following example set of numbers 2 times 2 times 2. Okay, we know that when we multiply that together, 2 times 2 is 4, times 2 is equal to 8. Okay, another way to represent this number is by using powers or an exponent. So it would be the number 2 raised to the power of 3, and that is equal to 8. Okay, 2 is the base number, 3 is the exponent, and 3 represents the number of 2's that are being multiplied together. So in this case, we have 3 sets of 2's being multiplied together. So the base number 2 is raised to the power of 3, which is equal to 8. Okay, now let me show you another example, and I'm going to just mix the numbers up so that it doesn't throw you off. 3 times 3 we know is equal to 9. Okay, another way to represent 3 times 3 is the base 3 raised to, there are 2 3's, right? So it would be raised to the power of 2. Okay, so 2 is your exponent, and that is equal to 9. So let's take a look at another example. Let's say we have 2 times 2 times 2 times 2 times 2 times 7 equals what? All right, so if we take a look at the number 2, we see that it occurs 5 times, right? So another way to represent that is 2, which is your base, and because there are 5 2's, we're going to raise it to the power of 5, and that's your exponent, times 7 is equal to some number. Okay, 2 to the 5, if you multiply that out, comes out to 32 times 7, and 32 times 7 is 224. Okay, so let's take a look at another example. Let's say we have 1/2 times 1/2 times 1/2 times 1/2, and that is equal to some number. Okay, so another way to represent this is we have a base of 1/2, put that in parentheses, and raise it to the power of the number of halves that you see. So there are 1, 2, 3, 4. So raised to the power of 4, and that is equal to some number. So 1/2 to the 4th power is equal to 1/16. So hopefully that made sense to you. Let's look at another example. We're going to go backwards this time. And here's what I mean by backwards. Let's suppose you see this. Okay, so now you know 1/3 to the 3rd power is really the same as 1/3 times 1/3 times 1/3. Okay, when you're multiplying fractions, you multiply across the numerator, and then you multiply across the denominator. So 1 times 1 times 1 is 1, and then multiplying across the denominator, 3 times 3 is 9, times 3 is 27. Okay, so let's throw in a negative number just to mix things up, to make sure that you've got some further understanding. So let's suppose we have -2 raised to the 3rd power. Okay, so what that means is we have -2 times -2 times -2, because there are 3 sets of them. That's what the exponent tells us. So -2 times -2 is a +4. Write that down here. and then 4 times and negative 2 is equal to negative 8. Okay, all right, so let's try this with some variables. Let's suppose you've got this. Okay, and we want to represent that in terms of exponents. Okay, the answer to this would then be, for m's we have 4 m's, y's we have 3 y's. So then that would equal m to the 4th power y to the 3rd power. Okay, one last example. Let's suppose we have s times s times s minus x times x times x times x. Okay, what does that equal to? Well, we have 3 s's here being multiplied together, and we've got 4 x's being multiplied together. So the way we would write this in terms of exponents would be s to the 3rd power minus x to the 4th power. Okay, hopefully that makes sense. As usual, if you need a repeat, go ahead and replay this video from the beginning, and hopefully that'll make more sense to you. Thank you.